Welcome back, Hononegah Honors, Algebra 2. Section 13.5 is Identifying Conics. So throughout this entire chapter, we did parabolas, we did circles, we did ellipses and hyperbolas, and that's all the different ways you can slice up a cone, and you'll see that pictured here. With that being said, how do I know which one's which? So if I'm just looking at an equation, I'm saying, well, that one is a circle or that one is a parabola. Parabolas, circles, and ellipses are called the conics because they can cross-section of a cone. So now, this is as many different terms that you can have in a quadratic. So I have an ax squared, I have a bxy, which we actually never get in this particular section, cy squared, dx, ey, and f. So those are all the different places we can have a term in a quadratic. So now, how do we know which one's which by just looking at it? Well, a and c will tell us all. So if there is no a and no c, I'm sorry, if you have no a or if you have no c, one or the other, meaning there's only one squared term, meaning you don't have an x squared or you don't have a y squared. That makes it a parabola. So if there's not an x squared and a y squared in the problem, that's the only way that makes something a parabola. The next one, if you have an x squared and a y squared with the same lead coefficient, so it's an x squared and a y squared. Both are positive or both are negative. Doesn't matter because then you can multiply everything through by negative. So x squared and a y squared with the exact same lead coefficient in front of both of them. Now, here's where things start getting a little bit dicey. You got to have an x squared and a y squared, both positive or both negative. Again, we can change all the signs. So the same sign, different lead coefficients. So if the number in front of the x squared and the number in front of the y squared is different, that makes it an elliptical shape. And the last one, if you have an x squared and a minus a y squared, so again, different signs or opposite signs, then that makes it a hyperbola. So just by looking at the equation, I can tell you what we have here. So the first one, 3y squared minus an x squared. So it's not a parabola because you have two squared terms, and one of them is positive and one of them is negative. That makes it a hyperbola. The 2x squared plus 2y squared. It's the exact same lead coefficient. That makes it a circle. The next one only has a y squared, no x squared. That makes it a parabola. X squared plus 4y squared. Again, it's got an x squared and a y squared, but different lead coefficients, both positive. Same with the next one. And then the last one, it does have an x squared and a y squared, and if I put them both on the same side, it's minus, which makes it a hyperbola. The shock wave generated by a supersonic jet intersects the ground in a curve given the following equation. What is the shape? Well, if I distributed this and I looked at it, I only have one squared term. That makes it a parabola. Now, identify the conic, meaning tell me what it is. Then put it in the correct form and graph. I don't have to answer all the questions that go along with it, but I just want to establish what it is, put it in the correct form, and graph. So I have a 5x squared and a 5y squared. Therefore, this makes this a circle. Now, 5x squared plus 5y squared plus 30y would equal 35. I'm going to complete the square with the y's. So I'm going to take a 5 out. Add 3 squared. Now, on the other side, I wouldn't just add 3 squared. I need to add 3 squared times 5. Y plus 3, quantity squared equals. Add that up, I get 80. Now, it is a circle. Circles, so I'm going to divide everything in the question by 5 because really with a circle, you don't want any lead coefficients. Now this is in the correct form for a circle. 0, -3 is the center with a radius of 4. So I went 4 to the right, 4 to the left, up 4, down 4, and connect the dots. So a circle. Next one. I see only one squared term in this question. So now x equals, so I'm going to solve it for x, -2y squared plus 12y minus 14. So I added 12y to the other side, and I subtracted 14 to the other side. Now, complete the square with the y's. I'm going to take out a -2. Half of 6 would be 3 squared times the -2 out in front. So that completes the square with the y. Add 18, and that puts it in vertex form. The vertex is at 4, 3. Again, 4 for x, 3 for y. Always make sure you're aware of what is inside the parenthesis. -2 is the lead coefficient. So if I go up into a sideways parabola, if I go away 1, I go to the left 2. Away 2, I go 8. 4a, 1a, 4a. And that is a parabola. I know I didn't write that down, but establish the shape and put it in the correct form. It's a hyperbola. Get the x squared, the x together, -6, -12y together, and put the constant on the other side. All right. Take out a 5. Half of 6 is 3 squared. Times the 5 adds 45 to the other side. That would complete the square for x. Take out a -6. Half of 2 would be 1 squared times the -6 on the outside. Add all that up. I get 30. Because ellipses and hyperbolas equal 1. I plus 1 quantity squared over 5 equals 1. So again, this is a hyperbola. Center at 3, -1, so +3, -1 is the center. I'm going to go on the x, left and right, the square root of 6, so that's slightly over 2. I'm going to go up and down the square root of 5. So again, that is slightly over 2. That creates your box. Then I'm going to draw in the asymptotes of the box. And because the x comes first, you're talking about a left and right hyperbola. So again, identify the shape, put it in the correct form, and graph. Your homework assignment is a worksheet. So it's a worksheet 13.5. If you have any questions, please make sure you talk to your teacher, and good luck.